Welcome to our webinar on Creative Video Understanding, Editing, and Generation. I'm Flora Zhu, a sophomore from Grand Neck South High School, New York State. I'm a student volunteer for the Planet+AI program. I'll be your moderator for this webinar. Our invited speaker today is Enyi Rao. Dr. Rao is a postdoctoral scholar at Stanford. He studies human-centered AI through creativity, multimodality, and film, which focuses on content generation, intelligent media editing and creation, semantic and cinematic analysis, aiming to build connections between AI and humans for collaborative intelligence and unleash human creativity and productivity. His works include ControlNet, AntiMid-Diff, MovieNet, Virtual Dynamic Storyboard, Virtual Film Studio, Shoot 360, and City NERF, with the MAR Prize ICCV Best Paper Award. His works have also been selected as the most influential papers by Paper Digest. He assumes a leading role in the organization of the Creative Video Editing and Understanding Workshop at CVPR 24, ICCV 23, ECCV 22, ICCV 21. He also serves as the program committee member for CVPR, ICCV, ECCV, SIGGRAPH, CHI, UIST, Neural PS, ICML, ICLR, AAAI, IJCAI, and ACMMM. He receives the PhD at MM Chinese University of Hong Kong. He has research experiences at Meta Reality Lab, Vector Institute, University of Toronto, and Hong Kong University. This event is supported by the National Science Foundation and also by the Tennessean Space Grant Consortium at UT. Dr. Rao will talk about the creative video understanding, editing, and generation. This talk will trace his recent research on the understanding, editing, and generation of creative videos. Dr. Rao, would you please share your full screen?
Yeah, thanks for the nice introduction, and also thanks for inviting me here. Can you see the screen now, like in its full size?
Yes.
All right, then let's begin. Yeah, and I think, yeah, Flora and I have a question before this. It's like how long we plan to have our presentation and how long for the Q&A? Do you have any, or I can control it?
Oh, so the whole meeting is going to be 1 hour, including the introduction and your presentation, also the Q&A part.
Right. Yeah. So I think, yeah, I also welcome all kinds of questions at any time. So my basic plan, I think, is like I may give the presentation like 45 minutes and then leave like 15 minutes for the Q&A. All right. So let's begin. So today I'm going to talk about creative video understanding, editing, and generation. So before that, at the very beginning, actually, I would like to talk a bit about the history of the videos. The first motion picture is created by Edward in 1878 at a farmer near our campus at Stanford. He used multiple cameras to take a series of photographs of a rider on a galloping horse. And 20 years later, George introduced the editing concepts into video. It originates from magic and is very much experimental. So this editing concepts has a very strong impact in today's creative video.
So some say the glass is half full, some say it's half empty. I think
So as a starting point of my research, so actually as the first year of my PhD study, so my supervisor told me my job is just to watch movies. So we watched like thousands of movies, and then we first built MovieNet, which is a holistic data set for movie understanding. As we thought that movies are going to be a perfect source to understand the story and cinematical parts for video. So along this line, we define some like a basic temporal unit for a story, like showing the left top is we define it as a scene. With this unit, we can intimate humans' behaviors in watching movies to recognize people accurately in an online manner as showing the right top. And also retrieve corresponding like a video segment according to a complicated paragraph or as a query. The graph-based method is able to enable us to clearly know like which person or what kind of actions are matched. And additionally, we also shifted the perspective from audience to creators and provide a new way to analyze it through some cinematical style. So from the understanding side, a key observation and I think opportunity for the research community is that with the well development of AI techniques, we can now get a multi-modal structural understanding of videos from a lot of aspects. And here is demo for one of my favorite movie, Titanic. And then we can see like we can do a lot of like understanding up here. So, and this temporal processing unit we propose as a theme is also quite useful and is already being used a lot of like industrial products. And here is an example from the Amazon Prime Video. If you use that, you will see they have a lot of like a tag, structural tag up here, and then you can quickly search what you want. And it's also used in some other like commercial products like Tencent or SenseTime. So equipped with such abilities to understand videos, can we further like utilize these abilities to help us understand how video is created? So to answer this question, let's first check out how video is created. So starting from the most straightforward way, because since a video is actually a series of image frames, and an image is a matrix of pixels, so we can generate each pixel, then a video comes out. So kind of like some opening thing or kind of like the demo showing up here. And we can like further think about it from another way. It's like a video can also be viewed as a result of a camera robot navigating in the 3D environment, where the action space is about its position, angle, focal length, and all other some sorts of like a camera parameters. For another scenario in specific scenario in TV shows, the video that present to audience comes from the editing of multi-view camera tracks. And this is our and it faces significant challenges about like how to select a suitable cutting point and also like how to pick up an appropriate view for the from the candidates. Furthermore, when we specify the scenario to a professional video case, for example, like movies, it's actually a very comprehensive process that is made from pre-production, on-stage production, post-production. So we know a good movie usually takes like several years across like thousands of people's work, and that combines people's efforts, language understanding, graphics, visions, and a lot of aspects to build up this. So from all these different aspects, we may notice that solely relying on human efforts may involve like long and tedious modification. But from the other side, like a machine can only like cannot really create what we need, as it's hard to control, because usually it's a black box inside, and we do not know what it is created exactly. So this leads us to think about the relationship between the human and computers, whether we could collaborate, figuring out the tedious parts for the human creation, and then design tools to better align with users' attentions and make our mechanisms to be more controllable, interpretable, and explainable. So to answer this question, I think I can share some of my research and starting from the pixels perspective. So in the past years, we have witnessed the many large-scale image generators. And in the 2022, we did some experiments with DALL-E 2. When we were intended to achieve some goals, we had to iteratively edit the prompts many times. And this process requires a lot of like trials and errors. So we propose a control net, which is a method to add conditional controls to large-scale text-to-image diffusion models. ControlNet is a method to control image diffusion models with different conditions, like edge image, boundary lines, human pose, and so on. So the architecture of ControlNet can be seen as 3 parts: using external control model, reusing pre-trained backbone, and using zero initialized convolutional layers. The architecture of ControlNet can be seen from these 3 parts. So we can start from the first one about why we wanted to use external model to process the control signals. Because its first advantage is like through this way, we can then utilize multiple external control nets and then combine them together to achieve multiple controls. Like the example showing up here, we can combine the body pose and the hand pose. And also using external control model also allow us to change the base model easily in a flexible way with various community models to achieve different styles. This also locks the base model weight and reduce the risk of overfitting. So I'd like to share some insights actually before our work. So in a paper called Sketch Guided Text Diffusion, they pointing out that actually the difficult part about using a sketch to control a diffusion model is about the difficult alignments of complex scenes with fixed and ambiguous semantics. Like the examples showing up here, you can see it's hard like to make the ball and the cat to be clearly generated. So this motivates us to find a stronger backbone to solve the semantic alignments and the understanding problem about the sketch. So this the example showing up here actually is the result from our control net. So we find, so this leads us to think about, so what is the backbone should we use? So we figuring out at the time when we develop a control net, the strongest backbone we can find out is the encoder of stable diffusion. And we find out that it is very strong and also suitable for our case because before our work, we figured out some previous work have validated its performance of the stable diffusion encoder in different areas like semantic segmentation and classification. So what we did with this strong backbone, so the way we do it is also allowing us to have the abilities to guess contents without an accurate prompts. So with this strong backbone, you showing up here is you can see that given an input of an image like this, and then actually it can interpret this content because we do not have a specified text up here. We just provide a very rough text prompt, like a high quality image. And then it's able to interpret it into different ways, like face or glass or some huton. So finally, the technique we used is zero initialized layers to connect the neural networks so that the pre-trained backbone won't be destroyed by noisy gradients at the beginning of the training. So let's show ablative study to validate this. So when we give diverse prompts as inputs, some prompts are insufficient. You showing up here is like without mentioning this is going to be a home. And some other prompts are conflicting with the prompt, or even without any prompts. So we can see that from the proposed full model, actually the full model can actually, we can handle all these cases. Nevertheless, when the pre-trained backbone is replaced, or when the zero initialized convolutional layers are removed, then the neural network loses the abilities to handle the conditional image without prompts. This may indicate that the encoder was destroyed during the training in the absence of zero initialized convolutional layers. So let's see some comparisons over some existing works. These are all the results from existing work, like a PITI or sketch-guided diffusion. So let's see the first example about how we can handle this input sketch. It has more rich details over there. And also for this case, when we input a segmentation mask, you will see the occlusions, the overlap of different semantic objects. But our methods can well handle this, like making the dog lie a better way, I mean, above the paper. And also for this fan example, you will see the baseline model is like totally confused all the lines over there, but our methods can still somehow provide some clear line over there. And also for the last example is about some reflecting reflections over there. So our methods can still somehow understand the content in the given condition from the candy map and then generate a better image. So then I will show some results and applications of control nets. So we can use control net models to develop practical content creation tools like line drawing guided diffusion, processing artistic images and special style like mega, implementing or even instructor prompts like instructor pixel pix, for example, like putting the house on fire, and also like style reference and merging. And what makes it more exciting is actually this tool actually indeed unleash the by providing such a good to use tool actually indeed unleash humans creativity. So we will find out that actually a lot of people on Reddit, they self-motivated to organize some battles about ControlNet, about using ControlNet to create images they like. And here are some of the results showing up here from this line, from this another logo, or even have some creative interpretations of the input. And here are some more examples, about users creating some beautiful results. And here is another example about giving you a shape, and then it can understand this shape and get some results. So in the next, so in the previous work, we talked how to bridge the gap and also allowing more controllabilities to users for them to create image. So in the next following projects called Animate Diff, we applying some similar ideas and then extend this work to video domain. So, but essentially, Animate Diff is a plugin model that can actually create, animate, personalized, can animate any image diffusion models to generate high quality results. And it can also because it's a plugin model, and also ControlNet is also a plugin module. So these two can also be combined together to achieve some video generation results. And then I will cover that in the later. But first, I will cover the key idea about the anime diff. So, because its key is about a motion module that learning the motion priors from data, and then we can insert this motion module to any like image diffusion model, and then it's allowing this image diffusion model to generate videos. So with these designs, and our methods is able to generate more stable videos, but does not require fine tuning in the inference time. So this is really helpful for common users because they do not have so expensive computational cost on the computational resources. But a key challenge up here is usually the gap between the video training data, or we say the public video training data we can use, what we use here is WebVID, is usually the quality is bad than its image counterpart, like the Lion 5B, in terms of the size and also the quality. So our key idea is about we wanted to decoupling the learning of the appearance and the motions. So it's like we utilizing the appearance features from the abilities from the existing image diffusion model, and our motion module is just irresponsible of learning how it moves. So the way to do it is like we designing a adapter to what we call here is like a domain eraser to elevate the navigate negative effects from the video training data. So the way to do it is we will have a small adapter at each layer and then train it on the image of the video training data. So which means we can extract images coming out from the video training data, and then we apply an adapter to make the whole stuff up here to generate images looks like what we say is like the low quality images comparing to the Lion 5B. And with this kind of fitting, because we can then remove such kind of adapters when we inference that, then it helps us to, so we're figuring out that with these adapters, helps us to learn much better motions up here. Because you can see like more the magnitude of the motions is more larger than the left. And also like this stuff, we can also like add like additional LoRa to the motion module. This is like additional LoRa, different from the previous adapters to erase the domain gap. So it can like generate different like motion patterns up here to achieving some like a camera movement style. So in the usage case, so what we use is like we will fit this like a motion LoRa and together with the motion module, and then to the model is just insert it after every layer, and then we can achieving some composing some like motion patterns up here. So in the end, the whole pipeline looks like this. So in the training, the first stage, we will add a domain like a eraser up here we want to elevate the negative effects from the video training data sets and make sure the model in the second part is purely learning the motions from the video data set. And then we can optionally also learn some like motion patterns up here, like the zoom in, zoom out, pan left, pan right. So this is about the whole training pipeline of animative. So with this, then we can further compose this plugin model with the control net and see, and get some results like here, and also some results like here. We can also like yeah, here's like a result from community about like retargeting the Netflix instruction video to totally different styles. And also it also allowing a lot of like input informations, like we can input the image to make it animate an image, or also we can like just animate input scribble, or even we can like have some keyframes for the scribbles and then making the models to stick together with that. So jumping out from the video creation from 2D, actually we also know like 3D presents better controllabilities and usually is binds together with the production workflow. So to produce a video more effectively on stage, we all know like people usually made storyboards as a production tool to guide the on-stage filming. At its core, it combines character actions and shot scale and movement. However, traditional static storyboards lacks the abilities to faithfully demonstrate the dynamic contents, and it requires drawing skills and times for artists to make, let alone the amateur creators that lack skills. But our tool, with designing a dynamic storyboard tools up here, can actually help it to create more efficiently. So the input to the our like a virtual dynamic storyboard is some formatted like story and camera scripts. But the challenge still lies in both the generation and also like the evaluation process. So the first point, because we know like if we wanted to generate a video in 3D, then we need to figuring out all this like action space is enormous, it's very large. And this usually will lead us to interframe abruptness and also like less meaningful camera motions. So our take here is to, by specifying the shot styles, then we can raise our manipulation levels from frame to shot, and then can significantly reducing the search space for appropriate camera configurations. And for the other part on the generation, because we know there are no universal criteria for the generated shots, so we resort to a data-driven approach that can discover rules from real movie data. So with this in mind, our tool first executes the story scripts and analyze the environment and the character's actions to provide constraints for camera. And combined with the short style scripts, the camera will follow some predefined cinematic subspace to produce multiple plausible shots. And in the end, the shot ranking network that learning from movie data can actually providing some score and some recommendations and help to assist user selection. So from a practical use, we see some hand drawing usually takes like hours to finish for a script like this. And this is our results. It takes less time, but you can also see very clearly it's like it can show everything and all the planning in a totally 3D space, visualized in a 3D. And then this visualization can indeed help the on-stage filming process to help it like to save a lot of like the cost for the production. So we also conducted a user study for both the storyboard designer and also for the downstream storyboard reader, which is the one who read this storyboard and applying it to practical videos. So we will see that there is indeed some trade-off among the flexibility and efficiency it can provide. But we noticed that because storyboard is actually a very standard tool in a standard workflow. So if you stick to that standard workflow, then you will better figuring out that these tools is more efficient. Because the storyboard itself is like a guidebook. because and then for the whole pipeline for the downstream like videographer, they just need to stick with what is presented and then filming accordingly. So in the previous projects, we are like designing like the camera and character behaviors based on some predefined rules. But we also know like rephrasing the character and the camera behaviors in the existing movie is also commonly used in practical filming production. And actually by combining these two, and actually we can rephrasing or like reconstructing the behaviors from existing movie, and then we can also applying additional control introduced in the previous work, and then to achieve our own goals. So the way it works is like I will briefly talk how it works. So how it works is like it will estimate first some character behaviors. What we the representation we use here is like some simple tracks. And then based on this characters reconstruction, and then we will utilizing nerve, because we utilizing nerve as a differentiable filming renderer, and then we can find out the best filming pose for the camera using the supervision signals from the image level signal. So here are some of the results. You will see this is example from La La Land. And then we can actually reconstruct its behaviors from it. And then we can also like applying some embeddings up here. And then we can like replacing one of the characters with our own digital characters. Here are more of these examples. So it works for one person and also for multiple people case. But sometimes, especially in our real life, it's not so easy to capture 3D. So in one of my SIGGRAPH paper, we studied a fake 3D captured by 360 cameras. So our tools can allow users to generate desired normal view videos in the post-processing. Because we know like the traditional methods need to specify the field of view for each keyframe, which is really time consuming and intimidating to common users. While our tool provides user-friendly control based on these semantic and cinematical controls, and then also provides some feedbacks from the network to the users. So the design Shot 360 took a collection of recorded panorama footage at the input and accepts high-level user control on the video lens, like semantic, focus, or the cinematical style. And then we produce like a normal view videos with desired content preference and styles. So to be specific, the system needs to firstly analyze the semantic elements, including building, people for each panorama shot. By selecting different focus on the semantics, we can further generate multiple shots, satisfying the requirements. And then the local and global ranking network will provide some recommendations and feedback to the users about the choice that about like which candidates we should choose up here. So here is one of the implementation of our approach in the interactive tool with control. And let me see if I can play this. Oh, yeah, but so it's like the feedback is coming out from the network can tell you like specifically the score about each component, how good it is comparing to some like professional made normal view videos. So the tool is also verified by a detailed user study among professional and non-professional groups. And I think both groups agree with its like high quality, and it's also more efficient for professional for them to take it as initial status, and they can further applying some fine-grained editing. But for non-professional people, they are just feels like it's more easy to get what they want and also like get their personalized content. So in the next, I will cover in the next. I will also briefly covering some of the projects in a few slides about some of my other research on the whole picture of this. So here is a study about we are like doing an editing or providing editing suggestions for a multi-camera TV shows and to playing cinematic directors for the TV shows or for the TV episodes. So the first example shown in the left is actually telling us how this like the choice of from different like camera angles can actually affect our viewing experience. And this is an example from a Japanese anime that it actually takes 8 episodes to actually tell the same story, but just from different shooting angles. And so how this can help us like to help with this like what we call the multi-camera editing. So we first construct a new data set that coming out from the TV shows, and it contains like 6 tracks synchronized the raw footage and one ground truth video created by the professional TV show makers, and also like covering like 4 various indoor and outdoor scenarios. And here is a glimpse of it. So we designing a simple baseline called the temporal and contextual transformer up here. So which is inspired from the observation that professional editors select a view based on the historical decisions they made and also all the available views at the current time step. So this has also been used in some real world usage case. And yeah, like I said, I will quickly covering some of projects briefly, and hope it can inspire some of your thoughts. Yeah, here is another projects that help the script writing process in the video professional workflow. So we know, I'm not sure. It seems the videos cannot. And I do it again. Let me see. Let me try to. Yeah, so because we know, like in traditional script writing workflows, creators usually begin by brainstorming and then write stories down with text-only interface. And they will imagine how these dialogues would be said by characters in existing movies. And to capture the tone and style of the movies in more detail, they will resort to such kind of like visual elements to bring a story to life. So, but what if we could like take these visuals a step further? So we introduced a script viz. It's a project that helped writers in their creation process to provide more visuals on the fly from the existing movies that enjoying the benefits of like following the cinematic guidelines and also like holding high consistencies among frames. So to fulfill this goal, we leverage the data we collected before, so the MovieNet, because it contains like over a lot of movies and also like rich annotations for all these aspects. So this input to the systems contains like 2 parts. So the one part is like the specification on the fixed and the variable attributes, and the second part is the dialogue. So with this input, ScriptViz can respond to the queries and retrieve satisfying frames from the movie database. So we can consider a scenario that a script writer wanted to write 2 people having an argument at a restaurant with our interface. The writer can use it to type in a fixed attributes on a page, like restaurants, but she's not clear about the other settings. The writer wants to characterize Bob as a confident or bit slightly arrogant through his interactions with Alice. So after considering the various settings presented by the variation, the writer opts for a nighttime ambience, establishing the scene's tone in contrast to the conflicts unfolding among characters. So the choice inspires the addition of a reaction sentence to Alice, and then she sets the gender of two characters to make it more specific. And here he figuring out the Ted movie is something that she wants, and then by seeing the characters is able to embody herself to the characters and then further refines her scripts. So in the final projects, I think I may want to share is in the final compositional stage is about um, adding some lyrics to the music videos. I think we can first play these music videos. Yeah, this is a cool video, but we feel like an essential part of the song, which is the lyric, is missing. So we are asking a question, can we converted the lyrics to the video, become a lyric video to enhance our viewing experience? So to actually make lyric video creation easy for people, so we build a pipeline that automates the entire process. And also we design a set of designing guidelines showing up here according to the text readabilities, the unified focus of attentions. So in the next, I will playing some results with our algorithms. I know the song might be a bit may not be so clear. Yeah, but yeah, back to the questions we proposed at the very beginning of my talk. So can human and computers collaborate better for our content creation? So through all the my thoughts on the video creation, I think through different perspective, I think the answer is yes, but still we need a lot of efforts to bridge them. So I think the way towards human-centered AI for creativity needs us to first figuring out the problems in the human creation. We need to know what's the tedious part, what kind of specific control we actually want. We need to start from real problems in the creation process and understand. So and then through this we can understand and improve a lot of human-centric properties like interpretabilities, the abilities in machines. And through this I think it's able to towards the building of more reliable interactions among them. So in the next so yeah, so starting from I think ICCV 21, I think together also with some other researchers, artists, we build a small group in this field that connects the computer vision, human computer interactions, and also a cognitive science. We hope this can open up more opportunities in this field. So in the end, I would like to thank the all of you guys, I mean, to listening to my talk and also inviting me here. And I'm also open to your questions.
Dr. Rao, thank you again for your amazing presentation. We enjoyed it a lot and we have some questions, so let's move on to the Q&A part. So my first question is, what do you think of the impact of generative AI in video on movie creations?
This is a very broad question. It's also a good question. Yeah, I think definitely it's not going to, it is a new stuff in, right? And then we also know like it's got a lot of issues like copyright. It also like it's black box, it's hard to control. Also from my perspective, for me, I'm also like seeking the answers about it. It's like especially when we talking today, I think mostly is what we call the generative AI, right? But I think our goal is like AI for good, but currently, we can definitely see it's not so good now. So my take would be like, it might be better like to think about the specific creation process to reduce the burdens. I mean, it's definitely not about replacing the job because we all know like a lot of the creating process, the creation decisions, this should be made by humans. And also like a lot of aspects that makes this kind of like movies, films good to or mean good or excellent for people to consume is especially about the manual efforts because we know like even for my personal experience I really love to see a lot of like the backstage stories about how people make these films, how let's say like how James Cameron they made excellent movies in 10 years. I think all the stories behind this is actually really uh, makes us feel exciting or feel us like appreciative about the content we create. But so in other words, if so we cannot like make the AI to replace all this stuff to tend it to an end to end. I think this is not a good direction. But to help the process, like to make it to be more structured, to be more can reduce a lot of like repetitive work that also human creators don't like. I think this is very inspiring.
Okay, thank you. Could you please comment on generative AI, human creativity, and machine creativity?
Yeah, yeah, this is also a good question, but also a kind of like a philosophy question, I think. Yeah, depending on how you defining creativity, right? Because if we define creativity as something totally new, right? Then yeah, I think you can think it from two ways, right? Machine can always create new, right? It can create a noise. You can say this noise is new,
Mhm.
but this noise, because it does not have any like background or the cultures associated with humans, so we cannot understand. So we do not call it like creativity, right? It's new, it's novel, but it's not creativity.
Mhm.
So from the other perspective, from the mechanism of how the current machine works, we all know actually it is a mixture of the training data, right? It learns from the training data. It's just a mixture, or it learns some manifold among the feature space, and then you can interpolate among that, and then you get some mixture, right? Yeah, this has a lot of issues, right? Definitely like aesthetical issues, like because you are combining a lot of artist work, but without giving credit to them. So this is my understanding for the how it essentially is. But another important way thing to think about is how we utilize this, right? It's like how we use it. The tool itself, it is just is, depending on how whether it's good or not is the way we use it. So from my some of my experience, I can think like Midjourney or a lot of like generative tools. I think it serves, or especially when we say the text to something, I think it serves different purpose as the existing creation pipeline, right? We all know like the existing creation pipeline we developed for so many years, right? We have yeah, if you have ever really checked like some creation process of like a specific movie, you know, like indeed it takes years of work and a lot thousands or 10,000s of steps, right? They need to make sure every layer, every step is correct. So I think it's totally different. So this is somehow maybe personal usage experiences, I saw that, I mean, the current a lot of like the generative AI tools might be more useful in terms of like providing some or at the very beginning of the stage, like you are also very not clear about what you want, and then it's like and then you see some examples inspires you, and yeah, but um we got to admit here, right? Sometimes still return something you don't want, but it's just a kind of like someone giving you back some reactions, and then this is my thoughts on it. Yeah.
Okay, thank you so much for your insights. So let's move on to the next question. Would you help with creating a collab notebook on Animate Diff so we can use Google GPU to make videos?
Yeah, definitely. I think because I personally does not it's not Google Notebook. It's called like Radio, or if you check the website, you will find like a Comify UI. It's also all sorts of like easy to use UIs, and then you can support you to create videos whether from text, or you can also like from video to video, right?
Right.
Mhm.
Okay. Thank you. Do you think your work will fundamentally change the video game industry?
Uh, yeah. This is again a good question, but also I think I don't know. It's like or we can say like every technology coming out will inspire some new stuff. I think it's not. Yeah, some people may say, yeah, like we will revolutionize, we will totally change. But my personal take is like um or my from my understanding, I may think it's just another type of like new tools, just like what we have before. Like we have VFX in the before, right? We and then we turn into, it's just a new type of techniques. Because we know, like even nowadays, we have so fancy VFX, visual effects, but still a lot of people enjoying like Christopher Nolan. He really enjoying the process of like building studios and then film in real world. So, but I think overall it's good. It's like providing more tools, more opportunities for us to create. But one more personal thinking is like I think, yeah, all of these are tools, right? We all know how to use VFX, but we cannot really create a good story as Nolan. I think there is definitely another part from the human part. Non-tech part is about how people tell story. I think this is really and also we all know like the storytelling also change through the time, right? So I think yes, so it should be a mutual process. Like technology can somehow help, but human still needs to like yeah.
Right. Like there are many like factors that might change the video game industry, right? Not only from your perspective, but also from like the storyline perspective, like just many factors. Thank you.
Yeah,
So,
or I may add like comments up here. It's like I saw that the current a lot of the tools, especially for the Gen AI tools that I presented in the first two projects, I think yeah, because they are focused on the pixels appearance. Yeah, so but we all know like the abilities to generate beautiful pixels does not mean, right? You can generate good films,
right.
generate good stories. That's totally different. So that's why in the next of my, yeah, I think in the next 3 or 4 projects I plan for the storyboard, for the script writing, is again is a tool to help the humans to create, to tell their own story.
Okay, thank you so much. So, one last question. So I personally am going to submit a project to the CVPR competition, and could you please give me some like tips and suggestions, please?
All right. You mean the you mean the art gallery? Are you submitting to that?
Yeah.
Um, yeah. I I don't know. This is really personal because art is really personal. It's my personal yeah. probably you can think from two ways, right? One is definitely like the tools you use, what kind of tools you use. But I think more importantly is like what kind of stories you want to tell, right? I mean, even there are many ways to tell story. You can use one single image can tell a very good story, right? You can even like one single shot to take a story, but you can also use multiple shots, multiple frames. But indeed, the way to tell a story are different, right? If you wanted to tell a story in a single image, it's different from the use. Yeah, if you have ever have experience on that. But my tip is just to tell your own stories. I think that's a good part.
Okay, thank you so much. I'll definitely tell my own story and then create maybe a good image or video. Yeah.
Yeah, yeah. If for the technology side, I think, I talked with some like a film school because I know like this because this is experimental, like to test the different creation workflow, right? Nowadays, um, yeah, if you search on Reddit or a lot on even on GitHub, people will also like to share a lot of their own workflows about making like yeah. So I think this is also something that can be helpful.
Right. Thank you so much. Dr. Rao, thank you again for your wonderful presentation. And thank you all for joining us today. Happy Lunar New Year. I hope to see you again on our next webinar. Bye.
Bye.